Hi, welcome to part 6 of the video series about the vertical projectile motion. In the previous videos, we solved some examples to understand how to use equations in this topic. In this video, we are going to solve another couple of examples. A tennis ball is thrown straight upward with an initial velocity of 15 meters per second. What is its velocity when it reaches a height of 10 meters above its launch point? Assume that there is no air resistance and gravitational acceleration is 9.8 meters per second square. As we've seen in the previous questions, first we choose direction of initial velocity as the positive direction. The magnitude of the initial velocity is 15 meters. Acceleration is negative 9.8 meters per second square as it is acting downwards. We are asked to calculate the final velocity when the displacement of the ball is 10 meters. An equation which contains all these quantities is V final square is equal to V initial square plus 2 times A times delta x. Initial velocity is 15 meters per second. Acceleration is negative 9.8 meters per second square and the displacement is 10 meters. Square of 15 is equal to 225. 2 times 9.8 times 10 is 196. Square of the final velocity is equal to 29. To calculate the final velocity, we take the square root of 29, which is equal to 5.39 meters per second. A basketball is thrown straight upward with an initial velocity of 20 meters per second. How long does it take to reach a height of 15 meters above its launch point? As usual, we start the solution by deciding the positive direction. The ball is thrown upwards, therefore, throughout the solution, we consider it as the positive direction. Initial velocity is 20 meters per second. Acceleration is negative 9.8 meters per second square as it is downwards. The task is to calculate the time it takes to reach the height of 15 meters. We can solve this question by using just one formula. Delta x is equal to the initial times delta t plus 1 over 2 times a times delta t square. It will sound strange, but usually using another two formulas instead of this one makes the solution much easier. It seems that using the first formula is a one-step solution. However, using it to calculate time will leave us with a quadratic equation, and solving a quadratic equation normally is not an easy task. Therefore, instead of using this equation, we are going to use these two. First, we are going to calculate the final velocity by using the equation on the left, and then we are going to use the result to calculate the time. Initial velocity is 20 meters per second. Acceleration is negative 9.8 meters per second square, and the displacement is 15 meters. The final velocity of the ball is equal to 10.3 meters per second. We substitute it in the second equation, where initial velocity is 20 meters per second and the acceleration is negative 9.8 meters per second square. Time to reach the height of 15 meters is equal to 0.99 seconds. In this video, we solved another two examples. More examples will follow in the next few videos. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.